Assalamualaikum, my name is HAZIMAH. Now I will explain Lab 5, Reduction of Multiple Subsystem. For part A, we are given a set of simulated model that represent a DC motor with shaft velocity output. There are two subsystems in this system. This is subsystem 1 and this is subsystem 2. And this is the controller. Okay, first we use a unit step to give the input to the system, and then there will be a feedback of 5, and it will be added using summing junction with the input RS, and then it will be combined with integrator 1/S, and then it will give output here, and then the output will become the input to the next subsystem, and there will be 5 here from input here, and then it will be combined with the output from 5 here, and then it will give the field voltage US, and then the US will become the input to the next subsystem, which is to find the current. Then there will be a feedback H2 from here, and then it will be combined using summing junction. It will be added with US, and then it will be combined with integrator 1/S, and it will give current IS. The output will become the input to the next subsystem. Okay, first it will be combined with gain 6. After combined with gain 6, it will become the input. Here it will give feedback 3, and it will be added using the summing junction, and it will be combined with integrator 1/S, and it will give the shaft velocity YS. And then we use the scope to plot the value. This is the plot of the DC motor. Okay, first from 0 to 1 second, the output still remain at 0, and then at time 1 second it start to raise, and at 2 second it achieve its peak amplitude, and it start to decrease, and it stay at value 1 from 0.3 second until infinity. This graph is an underdamped response.
Hi, my name is MARYAM and I'm going to explain part BA. In part B, a regular single transfer function is obtained based on figure 2 in the lab sheet by using Mason's rule. Mason's rule formula has components that need to be evaluated. To obtain transfer function by using Mason's rule, the block diagram needs to be changed to signal flow graph first. Next, loop gains are analyzed based on the signal flow graph. In this case, there are 3 loop gains involved, which are G1H1, G4H2, and G6H3. A loop gain must be found by traversing a path that starts at a specific node and ends at that same node. The next step after finding loop gains is to obtain non-touching loops. A non-touching loop is a loop that does not have any nodes in common. As for this lab session, the non-touching loop for 2 at a time is this, and non-touching loop for 3 at a time is simply this. In Mason's rule, the formula to find transfer function is CS over RS, where CS is defined by T1 delta 1 minus T2 delta 2. RS is defined as 1 minus loop gains plus non-touching loop for 2 at a time minus non-touching loop for 3 at a time. In this experiment, delta 1 and delta 2 is equal to 1. From the equation, H1 is equal to 5, H2 is equal to negative 2, H3 is equal to negative 3, G1 is equal to G4 equal to G6 equal to 1/S, and GS equal to 6. Then these numbers are filled to the CS over RS equation to get the answer as per shown here.
Is the diagram of figure 2
Once got the diagram, name the block of G1, G2, G3, G4, G5 and G6 and the feedback H1, H2 and H3 and then simplify it. First simplify the G2, move this to the next one after G1 and then we will get all the transfer function like this. After we'll simplify the G2 over G1 and G3, G4 and H2, G5 and G6 H3. Then we will get all the transfer function like this. Once got this block diagram, we will get this equation. CS over RS cancel off G1 and expand all the equation. And then we will get this equation. After that, then the detail of the subsystem, then sub into the value in this equation. And then we will get the result like this. After that, we will multiply by S3 over S3 of the transfer function. And then finally, we can get this equation as the last answer of the transfer function of reduction of the MATLAB coding for the part B. So first, declare all the G1 and all the H1 and also put the value into it, and then the transfer function will 1 is equal to feedback G1 H1, transfer function 2 will equal to G2 over G1 plus G3, transfer function 3 feedback and G4 H2, transfer function 4 is equal to G5 and transfer function 5 is equal to feedback G6 and H3. This is referred to the block diagram. After we'll simplify the block diagram, and then we'll get the final transfer function, and then we will evaluate the selection and we get the answer. So the final answer we will get like this, same as the calculation that we represent at part B, A and B. So that's all. Thank you.